In today's lesson, we're going to be looking at equations of circles. So we've been dealing with circles. Now we have their equation when they're placed on a coordinate plane. The standard form of this equation is going to be the following. It states that the quantity x minus h squared plus the quantity y minus k squared is going to be equal to r squared. X and y will be any point that lies on the circle. H and K is specifically going to be the center point. So H and K will specifically be the center. H will be the X value of the center as pictured. And then K will be the Y value of the center as pictured. And since it's all equal to R squared, we're going to make sure to note that R is going to mean the radius. And that will be squared at the end of this equation here. So we're going to go ahead and look at case number 1 where we're writing equations of a circle given the center and the radius. That's important to have both the center and the radius because we need all of those to write the standard form of the equation. Let's look at the first problem here where we're given the center at -1, 8 and the radius with a length of 16. We're going to go ahead and highlight our important kind of variables here that we're going to replace. The h is the x value of the center, and the k is the y value of the center. Radius will be our r here. So we have h, k, then r. We'll go ahead and replace them in our standard form. Keep the x minus, and then you're replacing h with -1, because that's what h is in this case. We'll have addition between the parentheses, start the next parentheses, y minus k, which is 8 in this case. Close the parentheses and square it will be equal to our radius, which is 16 squared. We'll clean it up just a tad bit. Two negatives end up making a positive here for our equation of the circle. And then 16 squared, when you do that in the calculator, you get 256. Next problem, we have the center again at 0, 6. Then we have the diameter. So what we'll have to do is take that diameter and divide it by 2. That will then get me the radius because we know the radius is always half of the diameter there. So make sure when you're plugging the number in the equation, you're plugging in 14, not the 28. Let's cross it out so we don't even use it. We're using r equals 14 here to replace in our standard form equation. Here we go. We have parentheses x minus a0. That's the value of h here. Let's close the parentheses and square it. Plus the quantity y minus, instead of k, it will be a positive 6 there, squared, and that's going to be equal to r squared. Clean it up just a tad bit here. We have 0 canceling out, doesn't need to be written, so that can actually just simplify to x squared there. That's what you'll see it more likely, but no, that means the center is 0 for the x value in this case. Then we do 14 squared, which gets us 196 because that we need the radius squared. Last problem number 3 of these, we have the center at 12, -5. 12 is our h, -5 is our k. Then we have the radius, which is the square root of 58. So we go ahead and start our standard form, parentheses x minus h, which is in this case 12, squared, plus between the parentheses, start the next one, y, minus a -5 is our k here. Then close the parentheses and square it. That will all be equal to our r squared. The square root of 58 squared. Let's clean this up a little bit. Two negatives here make a positive between the y and the 5. And then when you take the square root and square it, those are opposite operations, so they cancel out. You're left with just the 58 underneath. So what we'll cancel that out to is just 58 outside of the square root. The next case we'll have for writing an equation is when we're given a graph. We don't have the center or radius written like we did the first case, but we still have it easily visible. Let's go ahead and write the center. That's the point right here. We label it whatever point it is on the graph. So it looks like it's at -3 up 1, 2, 3, 4, 5, 6. So center is at -3, comma 6. You always put the x value before the y. And because it's the center, our first value is going to be h, and our second value is going to be represented as k. Last but not least, we'll also need the radius before going to write this in standard form. The radius is any point on the circle, the distance to the center. So we'll take any point, choose one that will be either vertical or horizontally distanced. Don't really go on the diagonal like here. It'll be easier to count horizontally or vertically because I can tell the distance on the graph between these 2 points is 1 space, then 2 spaces there, making my radius 2. Now we go right to the standard form equation right here. Start the parentheses x minus RH, which is -3, the x value of the center, squared, plus y minus, we're putting in k now here, but it's a +6, so it stays a negative there next to the 6. Close the parentheses and square it, and this will all be equal to our radius squared. So again, clean it on up by simplifying. 2 negatives make a positive, and then 2 squared, super easy, is 4. In our next case, we'll look at writing the equation of a circle given the center and a point on the circle. Most importantly, we have the center, but we're missing the radius. To find the radius, we will use the distance formula, as that helps us find the distance between 2 points. Specifically here, we want to know the distance between that center point given and the point on the circle, because that will be the length of the radius. We'll go ahead and try the first problem here. We're going to use the distance formula where we have the square root of parentheses x2 minus x1, close the parentheses and square it all, plus the quantity y2 minus y1, squaring that. Our x values are going to be the first numbers listed in each point, 9 and 7. And then our y values will be the 10 and the 4 there. So we'll go ahead and plug those in. It doesn't matter which one you plug into x2 versus x1, but whatever you start with, keep it consistent for the second. So we go ahead and do 9 minus 7 and then square it, plus 10 minus 4 and then square it. Answers come out to be 2 squared plus 6 squared. That's going to give us the square root of 40. We'll go ahead and leave it as a square root. No need to simplify here. What we're going to do now is, now that we have the radius, we are going to write the standard form of this equation. As a reminder, it's the quantity x minus h. In this case, h is going to be the 9 from the center here. Have to focus on the center. Don't use the other point when writing this equation. Plus the quantity y minus k squared. In this case, k is 10. again, the y value in my center point, and that will be equal to r squared. Remember we talked about earlier that when we do the square root of 40 and we square it, that cancels out the square root with the squared, and you're left with what's inside the radical. So r squared can be written as a 40 there. That's why we did not need to simplify the radical. For problem number 6, we have this same exact situation where we're writing a circle given the center. Remember the center, the x value is the h and the y value is the k. And then we're only given a point on the circle. We are missing the radius. But to find the radius, we just do the distance from the center to the point on the circle. So we're going to do the distance formula just like we did above, except we're going to use Desmos this time. For Desmos, you type in distance, start 2 parentheses, put in the first point, doesn't matter which one. Make sure to put a comma after the point you choose to go first. You're not multiplying them, you're listing them to find the distance between them. Second point, and then make sure to close the parentheses at the end. When you type this exact formatting in Desmos, you get your answer that the radius is 10. That's the distance between the point in the center and the point on the circle, known as our radius of 10 there. Make sure you have this exact formatting in Desmos and that you get 10 as well. We go ahead and put that it's equal to 10, which is going to be our radius. We now have all the information we need to write the equation of a circle. We have the center, h and k, and the radius, so we go right to writing it. Start your parentheses. We have x minus h. In this case, h is 5. Close the parentheses and square it. Plus, start your parentheses y. We're going to subtract the k, which is negative 7 in this case. Make sure to close parentheses and square it. And all of that will be equal to r squared, which is 10 squared. We go ahead and simplify this up by cleaning it. 2 negatives make a positive, and then 10 squared comes out to be 100. Final answer for you there for that equation of a circle here. Next case is that we're going to write the equation of a circle given the 2 endpoints of a diameter. So most importantly, when we go to problem number 7, it says that we want to write the equation of a circle with the endpoints of a diameter at the following points. As a reminder, here's a circle. The diameter is all the way through the center point connected to those 2 endpoints there. So what we're missing here is the center and the radius. We're given the endpoints of a diameter, so we can find the distance between those points, which would mean that would be the length of the diameter. So we're going to go ahead and use distance to find the diameter, which will then get us the radius. To find the center, that's the point in the middle, the diameter does pass through the center and specifically right in the middle of it. So if the center is in the middle of the diameter, then we just find the middle point using the midpoint formula between the 2 endpoints on the diameter. We'll go ahead and start with distance. We'll put that in Desmos just like we did the last problem. Start your parentheses, then start your parentheses for your first point. Put a comma in between the points, that way it comes out correctly. In Desmos, you go ahead and put that all in. You get your answer of 17.2. That's going to be the diameter though. So to find the radius, we go ahead and copy that number and just split it in half. Divide it by 2. Answer comes out to be 8.6 there. Because as we remember, the diameter would be the whole length, radius would be half. So that's saying here, we have 8.6 on the left of that green point and 8.6 on the right, making a total of 17.2. Now we got to find the center point. So we're going to use the midpoint formula in Desmos. Going to be the same formatting of the points. Instead of the word distance in front of it, we're going to have the word midpoint. So it works out really well that when we go back to Desmos here, all we have to do is change the word distance to midpoint up here. You can keep everything else. We go ahead and label it. We find that the center is 11, -8. That's also the midpoint of the diameter. So we go ahead and write it down here, 11, -8. That will be the center. Remember, h is the x value of the center, and k is the y value of the center. We now have the center and the radius. We can go ahead to write this equation. We have parentheses x minus h, which is 11. Close the parentheses and squared it. We have a plus between the parentheses before we start the next one. Y minus our k, which is in this case -8. Close the parentheses and square it. Will all be equal to our radius squared. Radius, as we found out before, was 8.6. We'll square that. Clean this up, make sure we have it in the simplest form. Two negatives make a positive. Then we go back to the Desmos calculator to figure out what 8.6 squared is. So we go back to the Desmos calculator to figure out what 8.6 squared is. So we go back to the Desmos calculator to figure out what 8.6 squared is. That's going to be 74 for the radius squared part of our equation. Now we're going to be working backwards. We're going to be given the equation of a circle and need to identify the center and the radius. As a reminder, the standard form of our circle is the quantity x minus h squared plus the quantity y minus k squared, and that will be all equal to r squared. So let's go ahead and label everything we're given. So it's x minus h, so this 9 will be our h. And it will be a positive 9 because we already had negative in standard form, and the negative is still there. Then we have plus the quantity y minus k squared. Well, it's here y minus 4, so I'm looking at 4 as my k. Again, a positive 4 because we already had the negative there in standard form. Last but not least, it's all going to be equal to r squared. So this 144 is really saying r squared is equal to 144. But I need to find the diameter. First, let's find just r. Solving this little one-step equation, instead of taking the square, we want to undo it by taking the square root. That way we can get r by itself. R is going to give us 12 here. To get the diameter, we know that the radius is just half the diameter, so we multiply that 12 by 2 to get the diameter of 24 in this case. Next problem here, same thing. Let's go ahead and look at our first set of parentheses. We have the quantity x minus 2 squared. H will be the value that's subtracted from x in this case. Because it's subtracted, we already have subtraction in the standard form, so I keep it as a 2 here. This is when things change. We have in our second parentheses the quantity y plus 1 and then squaring it. Well, as you notice here, there's not a negative next to r1, there's a positive. Two negatives make a positive, so in order to have this in standard form, we must have -1 there. That way, when I plug in k as -1, the negative's already there from the standard form. Adding in the negative, two negatives make that positive. Just showing you that there. Last thing is, again, This is equal to r squared, which is 10. So r squared equals 10. To undo the squared, we take the square root to get r by itself, and we'll just leave it as the square root of 10 there. Can leave it, cannot simplify it anymore.